Alrighty, welcome back. Here is your second video for pre-AP Algebra. I hope the first one went okay. We're going to talk about simplifying expressions and equations today, which should just be a review, but we're going to just get some of this out of the way, make sure that we're all good and in the same place. Vocabulary first, just to remind you, a term, all a term is the part of an expression that are added or subtracted. So the terms of an expression are always separated by either addition or subtraction. Like terms are terms that have the same variables to the same powers, which means that the variables are the same and so are the exponents. They can't be alike if their exponents are not the same. You cannot combine things that are not alike, which is why it's important to know what like terms are and unlike terms are. It's like adding apples and bananas. I know that sounds cliche, but that's what it is. You would not have 3 apples in one hand and 2 bananas in another and say, I have 5 apples. Because obviously you don't, you only have 3. So they have to be the same in order for you to combine them. It's the same kind of scenario. So like terms, let's just do some examples. 2a and 5a are obviously like terms. Another one would be 7a, because the variables are exactly the same. Not like terms would be like 2a and 5b. You see that the variables are not the same. 7c added to that, still not a like term because you still have different variables. On the same note, you can have more than one variable as long as all of the variables are the same, you're good. So you have 4xy and then 0.05xy. They both have an xy together. And so, 1.25xy is still a like term because the variables are identical. The coefficients in this case do not matter. The number in front of the variable it's not important. You have to look at the variables themselves. So like in the next example, 4xy and y are not like terms because one has an xy, but the other one just has a y. And so if you were to say 3x, that would also not be a like term because it just has an x. It doesn't have the y part with it. So the variables have to be the same, but the powers or the exponents also have to be the same. For example, z to the 4th and negative 2z to the 4th. The z's are the same and they both have an exponent of 4. So another example would be 3z to the 4th. If they are not alike, if the exponents are not the same, then they cannot be like terms. So you have 3z to the 4th and 3z to the 3rd. They cannot be the same because these little exponents are different. So this right here, 3z squared, is also not a like term because they don't have the same exponent. So there's the difference between like terms and unlike terms. Like terms are important. We want to be able to combine them whenever possible, and that's what we're going to be talking about today. So let's just talk about, do they look the same? For the first 3 examples, we just want to state whether or not they're like terms or not. So we're just going to look at them and decide if the variables and the exponents are the same, then our answer is yes. If the variables and exponents are not the same, our answer is no. So example 1, 4xy and negative 3xy. Just look at the variable part. You have xy and xy. The variables are the same, so yes, these are like. That should be a K. I don't know what happened with my little board here. Number 2, you have 2s squared and 5s. This s squared and this s, they're not the same. They do not have the same power. The exponents are not identical. So these are not like terms. So you have to say not like. I apologize for the alarm chirping. I guess Cole needed to go outside, and so I had to open the door. So take a look at the next one. I'll give you just a second to decide if they're like or not and write it down. You should notice that you have an A and a B, therefore the variables are not the same, so these are not like terms. Okay, easy to recognize. So numbers 4 through 6, it says, if possible, simplify it by combining like terms. To combine like terms, we're simply going to add or subtract the coefficients of the variables. But first we have to see if there are any terms that are alike. So look at number 4. I have 4x plus x minus 3. Look at your variables. This 4x and this plus x both have x's. The only thing is, this x right here does not have a number in front of it. There's no coefficient. That's because it's understood to be a 1, and we don't write the 1. We don't walk around saying 1x, we just say x. So anytime you have just the letter, it's understood that there's a 1 there. If you want to write it, you can, but you do not have to. But you need to understand that that means there's only one of them. Now these are like terms because they both have an x, and I can add them up. 4x plus 1x gives me 5x's. Now this minus 3, however, is not a like term, but I can't pretend it wasn't there. I can't ignore it. It has to follow along and be part of my simplified expression. So I've simplified that expression. Those two things mean the same thing. The 4x plus 1x minus 3 is the same thing as 5x minus 3. I've just simplified and put my like terms together. So look at number 5. Look and see if you have any like terms first. So I have, again, apologize, I have the x squared and the x squared. When you are doing this, please make sure you look at the operation symbol in front of your coefficient. So I have a 13x squared minus 10x squared. This minus sign goes with the 10, not with the 4. It's got to be what is in front of the coefficient. So when I combine these two, I'm really going to do 13 minus 10, which is 3x squared, because I had 13 of them. I took away 10, leaves me with 3 total. And then the plus 4, just like before, I can't ignore. It has to follow along. Now take a look at number 6. You have 12x squared plus 6x to the 4th. Do you have any like terms? No, you don't, because the exponents are not the same, so you just simply say this is simplified. There's nothing you can do to it, so it's all you can do. You just say it is simplified. So, sometimes we simplify expressions by combining like terms. Sometimes we do it by getting rid of parentheses. And sometimes the only way to get rid of parentheses is to do what we call the distributive property. It's called the distributive property, and it is called that because you're going to distribute. You're going to share the 2 outside of the parentheses to everything inside the parentheses. It's just a multiplication problem. Okay, what it means when I have a problem like this, 2 times x plus 4 together, I have to multiply this 2 times this x, and this 2 times this 4. Gets rid of the parentheses and gives me a simplified expression. So when I do 2 times x, that gives me 2x. My plus sign drops down because that's what's in here. And then 2 times 4 gives me 8. Distributive property is simple. It's easy. However, the most common mistake that gets made, and it happens all the time, we take something really simple and make it hard and make mistakes on it because we don't follow the rules. Most common mistake is you will distribute the 2 to the x and then forget to distribute the 2 to the 4. Always make sure you distribute to every number. If you got to draw the arrows, draw the arrows. But make sure you distribute to everything. So let's do a couple more examples. We're going to simplify some expressions by getting rid of the parentheses and then combining like terms. So this first one, number 7, we're just going to distribute first. So I'm going to do 4 times a, which is 4a. Bring down your plus sign. And 4 times 7 is 28. So you have now simplified. Now you are asked to evaluate it if a is 5, which if you'll remember from yesterday means I plug in 5 for a. And then I just do the calculations. 4 times 5 is 20. And 20 plus 28 is 48. So there it is, evaluated. Now, let's try this number 8. The thing that you have to distribute on number 8 is a negative 3x. So you have to take care of the negative 3 and the x also. So let's do this. So I'm going to do negative 3x times 4. So let's do the numbers first. Negative 3 times 4 is negative 12, and the x just gets to follow along. Now, you remember I told you a minute ago that if there is not a number in front of the variable, it means that there is a 1 here. We're going to have to remember some integer rules. So I'm going to have to do negative 3 times positive 1. A negative times a positive gives you a negative, so you have negative 3, And then you have x times y, which gives you an xy. Now, there's nothing here that is alike for me to continue to combine, so I am done. Now, number 9 tends to scare people because number 9 has a fraction in it. It is not a big deal. All a fraction is a division problem, plus this is a nice pretty one. I have to do 1/4 times 20 AC. Well, that means I got to take 1/4 of 20, which means I have to do 20 divided by 4. Well, 20 divided by 4 is 5 with the AC. And then I have to do 1/4 of 28, which is the same thing as 28 divided by 4, which gives me 7. So I'm now simplified. Okay. Number 11 here is a little different, and so I want to make sure that we cover this. Okay? This 18 has no parentheses or anything behind it, so it's going to drop down and follow along here. Now I'm going to distribute my 1/2. Well, half of 2x, well, half of 2 is 1, so I have 1x, and I've got the minus sign that came from that negative. Now, if I pretend that this 18 is not here, then all that's left is a negative 1/2. So when I distribute here, I have to do a negative 1/2 times a negative 4 because this minus sign also acts as a negative. When I do a negative times a negative, it makes a positive. And so half of 4 is 2xy. That's not the really tricky part. Look right here at this last set of parentheses, this part right here. There is a negative sign in front of this parentheses, but no number. Again, just like up here and the problem on the last page, that means there's a 1 here. So I have to distribute a negative 1 to this set of parentheses. Negative 1 times x is negative 1x. And negative 1 times y is negative 1y. So you've now distributed. Let's look and see, do we have anything that's the same? I do. I have a negative 1x and a negative 1x, and I can combine those so that I only have one x term instead of 2 of them. A negative 1 minus 1, I have 2 negative 1's, which makes a negative 2x plus 2xy minus 1y. There's your simplified expression. What I want you to do before you come to class tomorrow is try number 10 here. I want you to simplify it and then evaluate it. So I want you to try that before you come to class and we'll talk about it. So let's do a couple of word problems really quick. I told you yesterday that the perimeter problems were really important. You're going to show up a lot. So number 12, the length of a rectangle is 4x meters long. So it's 4x meters long. And the width is 8x minus 4 meters long. The first thing you're asked to do is write an expression to represent the perimeter. Well, if I'm going to find the perimeter, I think the easiest way to do this is to label all sides of my rectangle and add up things that are the same. So I'm going to add up all the things that have an x first. So 4x plus 4x is 8x, plus another 8x is 16x, plus another 8x is going to be 24x. So I've added up my x's. Now, I have numbers. I've got minus 4 and minus 4, which gives me minus 8. So you've now written an expression for the perimeter, and to evaluate it, if x is 3, you just are going to plug in the 3 and find out what that equals. I'll let y'all do that, and we'll check that answer again tomorrow. Let's do one more. This one's a pretty important question. Problems like this show up on the homework, on tests, on benchmarks, so I want to make sure that you get it. Number 13 says to find the perimeter of the square in terms of r, which means that r has to be in my expression. You see that r is the radius of a circle. Well, if r is the radius of a circle, then the diameter is 2r because it takes 2 of them. Well, if the diameter of this circle is 2r, then the diameter of both circles is going to be 4r, which is the distance across the square. Because from here to here is 4r, because this one is also 2r. And if I add those up, all the way across my square is 4r. So the perimeter of the square is 4r times 4 because there's 4 sides. And when you multiply that together, you get 16r is your perimeter. Okay, that is simplifying expressions. I will see you guys tomorrow. Have a great evening.